This video is over lesson 62, classifying triangles. It is for my 7th grade math class. So triangles can be classified in two different ways. They can be classified by their angles or by their sides. So we're going to start by taking a look at the angles. So first of all, a little bit of review. So when you look at this angle, what kind of an angle is angle A here? Hopefully you've called this an acute angle. And what makes angle A acute? Well, what makes it acute is that the measure of angle A, so that's how we talk about its measure, we put a little lowercase m in front of it, that the measure of angle A is less than 90 degrees. Now, if you've just said that, you're about half right, actually. It's not quite completely right, though, because the other side of this is it has to be greater than 0 degrees. So what makes it acute actually is the fact that it's between 0 and 90 degrees. If we move on to our next angle here, hopefully you should recognize this guy. That is a right angle. And when we have a right angle, we often use this little symbol here. It looks like we've made a square in the corner of this, because squares have all right angles. So that's our right angle symbol. And what makes this a right angle? Well, hopefully you've remembered that the measure of angle B to be a right angle has to be exactly 90 degrees. Not a little above it, not a little below it, exactly 90 degrees. And finally, angle C here is what kind of an angle? Hopefully you just said obtuse. Now, what makes this obtuse? Well, the most popular answer was that it's more than 90 degrees. But the full answer is that it's actually between 90 degrees and 180 degrees. So with that in mind, we're going to take a look at how to classify triangles by their angles. So if I look at these three triangles right here, these three triangles, then hopefully you're noticing that they have different kinds of angles within them. In fact, your mind is probably drawn to this middle one first here, because if we look at this middle triangle right here, we can see we've got a right angle in there. So this triangle right here has one right angle. And because of that, it's called a right triangle. If we take a glance at the other two angles here, what kind of angles are those? Well, the other two are acute. We're going to go over to this one next. This one, our eye is probably drawn to this angle right here, which hopefully you can see pretty clearly. This is one obtuse angle. And since it has one obtuse angle, it is called an obtuse triangle. If we examine the other two angles, so this angle right here, that angle right there, hopefully you can clearly see that this triangle has two acute angles. Now let's go back to this first one on the left. If we consider this angle and that angle and this angle up here, hopefully it's pretty clear that all three angles here are acute. So it has one acute angle and it has two more acute angles. So when all three angles are acute, we call this an acute triangle. Now, the reason why I set up our notes like this is because I want to emphasize that every triangle has two acute angles. Every single triangle will have two acute angles. But the name of the triangle will match what that other angle is. If I have a third acute angle, then it's an acute triangle. If the other angle is a right angle, it's a right triangle. If that other angle is an obtuse angle, then it's an obtuse triangle. Now if we come down to this example here, this triangle right here, this is an acute angle, there's another acute, there's another acute. So technically this is an acute triangle. But this is not just any acute triangle. This one's actually special. Because if you take a look, this angle is the same measure as that angle and is the same measure as that angle. And we use arcs to mark that those are the same measure, or we use the word congruent. This has 3 congruent angles. Well, we've learned previously that a triangle, the angles of a triangle, their measures always add up to 180 degrees. Well, if they're all the same measure, though, we can figure out pretty simply how much each of them must be. So 180 degrees divided by 3, each of those must be 60 degrees, which sure enough is 3 acute angles. So it is an acute triangle. But it's a special acute triangle. And since all of the angles have equal measures, we actually call it an equiangular triangle. Equiangular triangle. And let's go ahead and flip over to the back of our paper here. We're going to talk a little bit more about the angles of a triangle, learn some special relationships here. So it turns out that the largest angle in a triangle is opposite of the largest side. And forgive me, I had a little typo there. So just go ahead and kind of scratch that out and write side in. So the largest angle is opposite of the largest side. So go ahead and grab a highlighter. It really doesn't matter too much what color you choose. I happen to grab my blue. And so if I take a look here, the largest side of my triangle is right there. So it's not going to be angle A, that's opposite. It's not going to be angle B. This side touches both A and B. So opposite of this side here, opposite of side AB, is angle C. So angle C here must be the largest angle. The largest side is opposite of the largest angle. The largest angle is opposite of the largest side. So down below, that means, remember when we think inequalities here, so less than, greater than, think about a Pac-Man or an alligator eating the largest number. So where the mouth is open, this is where I'm going to put my largest stuff. So angle C here, the measure of angle C must be the largest. For that matter, the length of side AB, which we express as just AB, if we don't put a segment above it, remember that means we're talking about its length. So the length of segment AB must be the longest length on this triangle. Now if we go down to the smallest angle and the smallest side, here's my smallest side, and so it's touching A and C, angles A and C, so those aren't going to be opposite of it. Opposite of it must be angle B. And it's so tiny there that I can barely get my highlighter in there. And so what we see here then is the smallest angle must be angle B. So the measure of angle B is the smallest measure. And the length of segment AC, opposite of that, must be the smallest length of the triangle, side length of the triangle. Well, oops, sorry, I forgot to write the word opposite in here. So same idea, typo, fix that. Now, of course, we've got one pair that's left out. And I don't have a statement for this, but it's true that if you choose the side length that is in between the other two then opposite of that will be the angle whose measure is in between the other two. And so therefore, the measure of angle A must be in the middle, and the length of segment BC must be in the middle. So largest angle is across from the largest side. Smallest angle, across from the smallest side. Medium angle, across from the medium side. Looking at our next figure here, well, that's great for if I have something that's the largest, if I have just a single side that's the largest. But what if I have two that are the same? Like here, I'm going to put tick marks on both of these. Single tick mark identifies that any other side with a single tick mark has the same length. So here we have an isosceles, we have a triangle with two sides that are the same length. And so if that's the case, if I know that the two sides are the same length, so DE is the same length as DF, well then DE, which is right here, is opposite of angle F. So the measure of angle F, and then that must be equal to then, well, if this side, DF, is equal to DE, well, opposite of this is angle E. So therefore, the measure of angle E must equal the measure of angle F. And then finally, if we come over here, so we see this equiangular triangle again. So I'm going to go ahead and put in my arcs like I did before. And so if these three angles are equal, we can go backwards. So we know that the measure of angle G equals the measure of angle H equals the measure of angle I. Then their opposite sides must be equal in measure as well. So if I start with G, angle G, G is touching these two sides, so across from it must be that side. So across from G, angle G, is side IH. And then across from angle H is side GI. And then across from I must be GH. So what we see here is that if the three angles all have the same measure, then all the sides will have the same length. So those always come as a matched pair. And so with that being said, that's going to lead us now into our second category of classification, and that's classifying triangles by their sides. And again, my apologies, I had another typo here. Unfortunately, I caught it last year, but I forgot to actually go back and change it. So classifying triangles by their sides. And so we're going to ask, are there congruent sides here? And so obviously here we can tell that we have three congruent sides. And so just as when we were looking at the angles, we called that equiangular, well, now we're looking at the sides, we call this equilateral. So anytime a triangle is equiangular, it is also equilateral. That's what we discovered up here. So equilateral. And we're going to leave that blank alone for right now. We'll come back to it in just a second. Our next triangle here our next triangle, we have a side here and a side there that are congruent. Now notice I'm using double tick marks here because I used single tick marks there. And so I need to use double here to say that, well, these two are congruent to each other. This double is congruent to that double. They're not necessarily congruent, though, to the single tick marks. So this time, with just a pair of congruent sides, we would call this isosceles. So this has two congruent sides. So we don't have all three congruent anymore, just two congruent sides. Now, isosceles triangles can be just a little bit tricky because the definition actually says at least two congruent sides. So if you think about what at least means, it means that that's the minimum number. You could have more. Well, on a triangle, you only have so many sides. So really the possibilities are you could have two sides that are congruent, or you could have three sides that are congruent, which means that an equilateral triangle is actually isosceles. It's just a special isosceles triangle. And what makes it special as an isosceles triangle is that it doesn't have just two congruent sides, but the third side is also congruent. Whereas if you've only got two, then the only name that we can give is isosceles. And then finally, to finish this off, so thinking about congruent sides, so we have three congruent sides, two congruent sides. So if we're counting down, it seems like one should come next. But if you think about that, that doesn't quite make sense. How can you have just one congruent side? Congruence, just like, saying something is equal. If I say 4 is equal, well, that doesn't make sense all by itself. You'd ask 4 is equal to what? It's a comparison. There needs to be two things. So without anything else to make it congruent to, when we count down here to 1, it really means no congruent sides. And if there are no congruent sides, and sure enough, this triangle, if you were to take a ruler to it, none of those sides are the same length. This is called a scalene triangle. A scalene triangle. Now, ladies and gentlemen, as you are answering questions in your homework, please be aware that every triangle has two names. It has a name based on its angles. So does it have any of these large angles? That's what you're going to ask yourself. If it has a right angle, call it a right triangle. If it has an obtuse angle, call it an obtuse triangle. If it doesn't have any large angles, if they're just all acute, call it an acute triangle. If all three angles are congruent, this is a special acute triangle, in which case we'll call it equiangular. But then every triangle also has a name based on its sides. So equilateral, isosceles, or scalene. So be aware, it is possible to have an acute isosceles triangle. Actually, that's one right there. It is possible to have a scalene obtuse triangle. Actually, that's one right there. It is possible to have a right scalene triangle, like this guy. Now, when it comes to equilateral and equiangular, remember they always come together. They're always a pair. So typically when we have a triangle that is both equiangular and equilateral, we usually just call it equilateral. So as you're answering your homework, if it asks you to classify it by its angles and its sides, make sure you give it both names. And that, ladies and gentlemen, is our lesson.